Assalamu alaikum guys, welcome to a new lecture for a new chapter of IGCSE and O-level chemistry, and this chapter is called Stoichiometry, or more commonly known as moles. This is one of the most important chapters of your IGCSE and O-levels, and we'll kick off with this chapter. One thing I want to tell you before we start with this chapter is a lot of students find this chapter really difficult, right? Because it's all calculation based, right? So we're going to break it down into 9 different sections, and I've broken down these as you can see on the screen. So there are 9 different sections according to your syllabus for this chapter. So first we're going to learn balancing equations, then we're going to learn formula usage, then we're going to learn empirical and molecular formula, and then percentage by mass, percentage purity, percentage yield, ionic equations, isotopic mass, redox, right? So these are the 9 different sections you're gonna learn in this chapter. And we're gonna take each and every section one by one in great detail, right? This is your syllabus content, and I've made it more clear due to the topic division, right? So let's kick off with the first topic, which is balancing equations. So we will learn how do we actually balance the equations. Now, equation balancing is a very simple task, right? However, some equations are really tricky, so you gotta do some method to figure it out. So let's start with the very first and basic equation, as you can see on the board, right? So this equation says that H2, H is hydrogen, so 2 atoms of hydrogen makes up 1 molecule, right? So H2 reacts with oxygen to form H2O, which is your water, right? Now, how do we actually balance the equation, and why do we actually need to balance the equation? Because in chemistry, the rule is really simple, right? The rule says that whatever moles of product is formed, the same number of moles has to be there in the reactants for each element. What do I mean by that? For example, in the reaction, you can see there are two sides, right? This side is the reactant hand side, the one before the arrow, and the one after the arrow is called as product hand side, right? Now we need to make sure that all of the elements are same on each side. The number of elements must be same, right? So if there are 2 hydrogens here, 2 hydrogens are also here, so that is balanced, right? But if we see oxygen on the reactant hand side, we have 2 oxygens, but on the product hand side, we only have 1 oxygen. So how do we actually balance that equation? We just need to multiply. Whenever we balance an equation, we need to multiply. We need to add some multiplier to your reactants or your products, right? So if we multiply this product, this whole compound by 2, that makes up 2 molecules of H2O. So this 2 is actually multiplied by this H2 as well, and this oxygen as well, right? So now in total you have 4 hydrogens, because 2 times 2 is 4, and 2 oxygens here, right? So now we have 4 hydrogens here and 2 oxygens here, and we have 2 oxygens here and 2 hydrogens here, right? So now still we're in a problem, because oxygens are now balanced 2 and 2, but now hydrogens are here 4, and here we have 2. So if we add a multiplier here, a 2 here, that makes up 4 hydrogens here, 4 hydrogens here, 2 oxygens here, 2 oxygens here. That is a very simple task, right? So let's practice some more equations. How do we balance that? We just need to add multipliers, right? Now let's see the second equation, this one, right? Now we can see we have, this is the reactant hand side and this is the product hand side, right? So first we need to see how many atoms of each element do we have. Let's start with carbon. This is the carbon, right? Remember, this is C is with the L, right? It's followed by L, so it's chlorine, it's not carbon. This is carbon and this is chlorine. Okay, so don't confuse yourself with the C's. So in the reactant hand side, we only have 1 carbon. And how many carbons do we have on the product hand side? It's also 1 carbon, right? So we don't need to multiply anything for the carbons. Let's see chlorine, right? So on the reactant hand side we have two chlorine atoms, and on the product hand side we have four chlorine atoms, right? Now how to make this four? We can multiply this by 2, right? So now that makes up 2 times 2 is 4 chlorine atoms here, because 2 times 2, and 4 chlorine atoms here. But wait, we have a problem. We have a fifth chlorine atom as well, right? So this can't actually work. So now we gotta figure out another way to balance it. So let's first check the other atoms. So let's first see hydrogens, suppose. So here we have 4 hydrogens here and 1 hydrogen here. So what to do to make it 4? We just multiply this by 4. And if we multiply this by 4, then we check the chlorine. So that makes up 4 chlorines here and 4 chlorines here. That makes up total 8 chlorines on the product hand side, right? And here we have 2 chlorines. So how do we make 2 8? 2 times what is 8? It's actually 4. If I multiply this by 4, that makes up 8 chlorines here. So that is, sorry, that's going to be 4. So 4Cl2, and now we have 4 times 2 is 8Cl2, 8 Cls actually, and here we have 4 Cls from this thing and 4 Cls from the other substance, right? So that makes a 8 chlorines on both sides, 1 carbon on both sides, 4 hydrogens here and 4 hydrogens here. Very easy, right? Let's move on to the third equation. Now this is basically hit and try, right? You gotta do trial and error again and again to basically figure out the equation. But once you do enough practice, it gets easier. Trust me. So let's start with the third equation, right? So let's see. We have aluminum here and we have aluminum here. 1 and 1. That's balanced, right? What else do we have? We have let's say we have chlorine. We have 1 chlorine here and 3 chlorine here, right? So how do we fix this? If we add a 3 here, that makes up 3 chlorines here and 3 chlorines there. 1 aluminum there, 1 aluminum there. So chlorines and aluminums are balanced. What about hydrogens? If we check from this point of view. So in this thing, in the reactant, we have 3 hydrogens. In the product, we have 2 hydrogens, right? So that doesn't really make sense, right? Because it's way off. So we need to apply a different method to fix it, right? So let's just add a 3 here for now. So 3 HCls, right? Now this makes our chlorines 3, this makes up aluminum is 1 and hydrogen is 3 on the reactant and 2 on the product, right? Now how do we make this 3? What do we multiply here by 2 to make it 3? 2 times what is equals to 3? It's actually 1.5 or 3 by 2, right? So if we multiply this by 3 by 2, that will fix our answer, right? So now we have 3 hydrogens here actually, because this is 3 by 2 times 2, so which is actually 3. So 3 hydrogens here, 3 hydrogens here, 3 chlorines here, 3 chlorines here, 1 aluminum there, 1 aluminum there. Now whenever you multiply an equation in your IGCSEs only and O levels, whenever you multiply the equation by a fraction or a decimal, you gotta multiply the whole equation by 2. This is the rule, right? Because you can't just multiply by fraction, right? So you multiply this whole equation by 2. What do I mean by that? I mean, we need to multiply each and every substance in the reactant and in the product by 2. So we'll put 2Al. Why 2Al? Because if there's nothing written, it just means 1, right? So 1 times 2 is basically 2. If this is 3, 3 times 2 is going to be 6, right? So this is going to be 6, right? And this is just 1. So we'll multiply this by 2. So this makes up 2AlCl3. And if we multiply this thing by 2, that makes up 3, right? So this will make up 3. And that will balance your equation, right? I know it sounds a little tricky, but it's going to be fine. We're going to balance another equation just like that. Okay, so now let's move on to the next example. You can see this one, right? Now, this is also really easy. You just need to be focused. So there are two parts, right? There is a reactant hand side and there is a product hand side, right? We need to check each and every element. So if we can check, there is 1 nitrogen here on the reactant, one nitrogen here on the product. That's clear, right? If we see oxygens, we have two oxygens here and two oxygens here. That is also balanced. But if we see hydrogens, we have three hydrogens here and two hydrogens here, right? So we gotta fix this, right? If I multiply this by 2, right? So now we gotta really think of a common number that can be multiplied on both the sides. So now if I multiply by 2, let's just take it for now. So 2 times 2 is 4 hydrogens. Now we can't really make 3 hydrogens 4 hydrogens, right? So that's kind of a difficult task. But if I multiply this by 3, that's a common number, right? Because this will make up 6 hydrogens, 3 times 2. And if I multiply this by 2, this will make up 6 hydrogens, right? So it's basically the LCM. So 3 and 2 is LCM. So what's the LCM of 3 and 2? It's gonna be 3 common, and this is like the one we used to do way back. So 3 times 2 is gonna be 6. So 6 is the LCM, right? So we need to make it the least common multiple. So how do you make this 6? We multiply by 3. How do you make these hydrogens 6? 3 times 2, 6, right? But now as a result, our other elements are disturbed, right? Let's first fix up the nitrogens. We have 2 nitrogens here and 1 nitrogen here. So if I just multiply by 2, this will fix up our nitrogens. And now we'll check our oxygens. Now we have 2 oxygens here and 3 oxygens here. That makes up 5 oxygens. And now here we have only 2 oxygens. Now how do we make 2 oxygens? What do we multiply by 2 to make it 5? We multiply it by 5 over 2, right? Because in the product there are 5 oxygens, on the reactant there are 2 oxygens. So what do we multiply by 2 to make it 5? It's just 5 over 2, right? Or 2.5. So now we are multiplying a equation by a fraction, right? So we multiply by 2. So what's the rule? The rule says that whenever we multiply with a fraction or decimal, multiply the whole equation by 2. Make sense? So now if we multiply this whole equation by 2, the corrected equation, what do we get? 2 times 2 is going to make up 4. So this will make up 4NH3. 5 over 2 times 2 will make up 5, right? 5 over 2 times 2 will make up 5, right? So this will be 5O2. 3 times 2 is just going to be 6. And 2 times 2 is going to be 4. And now automatically, if you see, our equation is balanced, right? So this will make up 4 nitrogens here, 4 nitrogens here. 4 times 3, 12 hydrogens here, and 6 times 2, 12 hydrogens here. 5 times 2, 10 oxygens here, 6 and 4 oxygens here. That makes up 10, right? 6 from this side and 4 from this side. That makes up 10 oxygens here, right? Pretty easy. Now let's see the other equation. Okay, now in this equation, what are we going to focus? We're going to focus on another major thing you need to keep in mind for balancing equations. We're going to make sure that this whole thing that's in the bracket, this is called a polyatomic molecule, right? So this PO4 is basically phosphate, which is a polyatomic ion or polyatomic molecule, whatever you want to call it. So we're going to consider this as a one whole thing, right? Because PO4 is just one thing. If I multiply this by 2, this PO4 becomes 2, right? You can also calculate it separately. 2 phosphorus, 4 times 2 is 8 oxygens. That is also another possibility, but that just makes our life more difficult, right? So we're going to consider this whole thing as one, right? So the very first thing I can observe is on the product hand side, we have 2 PO4s. Can you see that? We have 2 PO4s. Just like we had 2 oxygens here, we have 2 PO4s here, right? So if I multiply this whole thing by 2, we're gonna make sure by that our PO4s are 2, right? Now let's balance the other parts one by one. So now we have 3 times 2, 6 sodiums. This Na means sodium, right? So now we have 6 sodiums here. 3 times 2, and we have only one sodium, so let's just make it 6, right? By multiply by 6. So if I multiply this one by 6, that makes up 6 sodiums here, right? Now let's see our magnesiums and chlorines. So let's see magnesium. There are 3 magnesiums here and only 1 magnesium here. If I multiply this by 3, maybe that can solve our answer. So that makes up 3 magnesiums here, 3 magnesiums here, and 3 times 2, 6 Cl here, and 6 Cl here. Very easy. That's balanced, right? Let's move on to the next equation. Now in this equation, what are we going to see? We're going to also do our balancing one by one, right? So we have 3 carbons here and 1 carbon here. So how do we fix this? How do we make them 3? How do we make this one 3? Just multiply this by 3, right? Next, let's check the hydrogens. So if we have 8 hydrogens here and 2 hydrogens here, how do we make 2 8? What do we multiply? We multiply by 4, right? So if we multiply this by 4, that makes up 8 hydrogens, right? 4 times 2 is 8. And lastly, let's just check oxygens. So in the product hand side, we have 3 times 2, 6 oxygens from this molecule and 4 oxygens from this molecule. That makes up 10 oxygens in total. So in the reactant hand side, we also have to make 10 oxygens, right? So how do you make 210? We just multiply by 5, and that's just solved our answer, right? So that was the first part of our lecture, first topic of moles balancing equations. If you practice more of these, you'll get the hang of it, and it's just trial and error. So just keep on practicing. Ask your AI or ChatGPT some of the easier equations, and then medium, and then hard, and solve those one by one, and you'll get the hang of it. Okay, bye bye, Allah Hafiz.